So here are some particular trends which the Gartner report emphasizes. Bring your own everything, which is more usually known as bring your own device, so that business employees use their own smartphone or their own tablet because they all have, so you don't have to have special business devices. Everything is smart. Namely, you have little computers and everything, so you have smart grids, smart sensors, smartphones. We have the big data revolution. We have very powerful HCI interfaces, human computer interfaces. Apple is hugely successful a company because of the innovation in their interfaces. There are some areas which are not terribly relevant here, near field communication for enabling better ways of paying for things. That we know a lot about people, including their voice prints. 3D printing is important. And then we have what they call implicit trends, consumerization of IT, where the IT is adopted by consumers ahead of enterprise, government, and science. And that is another way of saying industry, because industry largely serves the consumer, at least the IT industry does. It's ahead of universities in many areas. You'll find better work on data analytics in Amazon and Netflix than you will in most universities, if not all universities. And of course, everything is connected because we have the internet. That's the Internet of Things. The world is a set of things sitting on the internet, communicating with each other, or maybe communicating largely with clouds, where clouds actually collect together the world's data and information and knowledge and wisdom. So here's a set of the 14 of the 48 technologies are consumer related. Consumerization appears not to be a technology, it's a trend. And we have media tablets here. There's near field communication for payment. Virtual worlds are they've been tried to come along for a long time. I remember at the end, nearly around 2000, VMRL and other things are meant to revolutionize the world, and they failed because the internet and the computers were not powerful enough to support them. But now virtual worlds are more, at least technically possible. Whether they prove to be adopted by lots of people, we'll have to see. Here we have understanding data, activity streams. That's basically big data, set of events where you just record everything. The broader concept of big data, again, event processing, complex events, cloud sourcing, where you get a group of people together to make decisions. The analytics is done in memory, and rather than setting things in disk, it's faster in memory. We're analyzing social data, we're making predictions, and we're analyzing text. So this is all big data related technologies or applications. We have connecting things together, Internet of Things, machine-to-machine communication services. In this model, where we build software as a service, we need to connect these services together, and that's done by machines accessing machines. So when you normally think of services as having a client-facing interface, but that same interface has much to do with machines interacting with that service as well as people. Because when you string a whole bunch of services together, it's only the last service which connects to a person, or the other ones connect to other services. While Internet of Things and mesh networks are, in my opinion, essentially the same thing. Sensors are the enabler of the Internet of Things. So we have a lot of AI issues. The fact that we can now take all, this actually is all connected to big data, because we have enough data, we can actually make better conclusions than we did in the past. And speech analytics and analysis of audio data, recognition of content, these are all AI coming from teaching computers to do things. We have vehicles where, again, we're analyzing the data from the sensors and webcams on the vehicles. We have authentication built around biometrics, which are much more reliable. We have, you can wave your hands and control your computer. We could augment humans with computers. Mobots are coming more powerful because of the AI, and the fact also robots can access the cloud to make progress. Natural languages processing and using them to answer questions is getting more powerful. That's all coming from big data enable us to actually do a better job of recognizing what people mean when they write things. And of course, speech recognition and is still sort of is getting better, although it's still not. Still has limitations, in my opinion. So if we talk about improving efficiency, cloud computing is put here in its various versions. A hosted virtual desktop is essentially cloud computing. An in-memory database is a core idea of cloud computing. And idea management is, again, a sort of technology enabled by modern data technologies. So these are all computing and big data technologies. Here we have various things such as quantum computing, which are the future, 3D printing of various types. And of course, wireless power will be wonderful. Everybody hates all the cables we have linking things together. This is just an illustration from Gartner of the growth in the cloud area. We have we have infrastructure as a service, platform as a service, software as a service, and business process as a service. And you can see how they're growing rapidly in volume here, just exponentially increasing. And here's the actual increase as a function of year, and you can see that infrastructure service is highest. That's maybe slightly surprising because it's the simplest at 41.7% compound annual growth rate. Platform as a service is only 26.6%, and actually the highest level, software as a service, which you might have expected to be the biggest, because it's really the crunch point, because all of this other stuff is only important if you actually deliver software as a service. That's 17.4%. And here we have business process as a service. It is relatively similar to software as a service. So it's a particular software as a service product.